Centripetal acceleration. We know that when a body is moving in a uniform circular motion, its speed remains constant. Okay, but the velocity is changing due to the change in the direction. So we say that this body, which is in a uniform motion, it is always an accelerated uniform motion because of the changing directions of velocity. So because it is accelerated, so therefore the body which is moving in a circle, it should has an acceleration, and that acceleration is known as centripetal acceleration. And the directions of this centripetal acceleration, it is always directed towards the center of the circle. Okay. Now let us discuss about the derivation of the centripetal acceleration. Okay. Now let us consider this is a circle having a center at O and the radius is R. Now consider that at point P, the velocity of the particle is v1, and at point Q, the velocity of the particle is v2. Now the directions of v1, it should be tangent to this point P, that means acting along this direction. Direction of v2, it should be along this direction. And in this time interval, let's say the time taken to go from P to Q is delta t. So within this small time interval delta t, the angular displacement which is made by the particle is delta theta. Okay. Now, if we draw, if we take a point A here and we draw a line AB which is equal and parallel to the velocity vector v1. So we get this. This is v1, we draw parallel like this. This is v2, we draw like a line AC here. And then if you use the triangle law of vector addition, we can draw a line BC to become the closing sides of a triangle. So using triangle law of vector addition in this in this triangle, if you use the triangle law of vector addition, in this figure, figure number B, we can say it is V1, or I can say AB arrow plus BC arrow, taking in the same order, it should be equals to the third side AC arrow, which is taking in the opposite order. Or I can say instead of AB, it is V1 arrow, BC is delta V arrow, AC is V2 arrow. Or delta V arrow is equals to V2 arrow minus V1 arrow. Okay. Now, if this delta t, which is the time interval for the particle to go from P to Q, if this delta t is very small, that means let us imagine that delta t almost tends to 0. Okay, so in that case, when this delta t is so small, do you think that this point Q, it will be far from point P? No, because for a small time given, for a small time interval, the displacement covered will be small. Okay, so in that case, this point Q will be very close to point P, and if it is close to point P, then this arc delta S, or the arc PQ, it becomes like a straight line or a chord PQ. Okay, so please remember the arc PQ, which is a curved path. Now, when the time delta t is very small, then what happened? When the time is very small, then if this is a point P, then a point Q will be here. Point P, point Q. This is point P, this is point Q. So this curve here, it behaves like almost a straight line. That means the curve PQ becomes like a chord PQ, like a straight line. Okay, so then if that is the case, for a small time interval delta t, this OPQ, it becomes like a triangle, right? That means if you forget, right, because this is a curve, but for a short time, I told you that this PQ, this arcs become like a straight line. So OPQ now, OPQ Now it becomes a triangle. Okay. So then, when you compare the two triangles, OPQ and ABC, you will find that these two triangles are similar. Okay. Triangle POQ is similar to triangle ABBAC. Okay, so in class 10, I think you might have learned about the similarities of triangle. So when two triangles are similar, the corresponding sides are proportional, which means the sides PQ, therefore I can say that PQ upon BC is equals to OP upon AB. These are the corresponding sides of the two triangles which you have learned, right, in class 10. Okay, now instead of PQ, what is PQ equals to? PQ is equals to delta S. What is BC? BC is delta V. OP, it is R. AB, it is V. Only when I say AB with no arrow, it means only magnitude. So only magnitude. What is the magnitude of velocity at this point and at this point? The magnitude of velocity is the same. Only the direction is different. So when the magnitude is same, so I will write it is equals to V, because magnitude of V1 and the magnitude of V2 is the same. So this is equals to V. Okay, so I'll write V here. Next, delta S, taking delta R here, here you will get delta V upon, sorry, I made a mistake. We have to do it this. This is delta V, okay, delta V upon delta S is equals to V upon R, right? So just shift or cross multiply. Next, after this, what we do is we divide both sides by, okay, before that, let me write in this way. Again, make a mistake. Okay, so sorry. So just delta V, it will be V, okay, upon S, V upon R, delta S, right? So after these steps, what we will do is we will divide both sides by delta T. So when you divide by delta T, you will get delta T here and you'll get the T here. Now taking limit both sides of delta T tends to 0, you get delta V upon delta T. Here V upon R, and the limit is for delta S upon delta T. Okay, now what is this? Limit delta T upon delta V upon delta T, this is equals to dV by dt. This is equals to V upon R, and this limit delta S upon delta T, this is ds by dt. Now this dV upon dt, it is actually the acceleration, the linear acceleration. But this linear acceleration, it should be acting along the directions of the change in velocity. So as you can see here, the directions of the change in velocity, it is acting this side, this way. Okay, so if this is V1, this is V2, then the change in the velocity, the directions will be acting towards the center. So that is known as centripetal acceleration. So instead of this dV by dt, I'll write AC, and this is equals to V upon R. And for ds upon dt, this is what? Linear displacement upon time. This is known as linear velocity. Or we can say AC is equals to V square upon R. So this is the expressions of the centripetal accelerations for a particle moving in a uniform circular motion.